In this video, we are going to talk about differentiating using power rule. So all the function where power rule can be applied, we are going to look at it. Let's talk about the learning objectives. So at the end of the video, you should be able to differentiate a function using power rule. Now some of the notations that we are going to use when we have a function y is equal to f of x, we say we're going to find dy over dx. That means we are differentiating the y function with respect to x. So if we have a function of y in terms of x, this is how we denote. Differentiate y with respect to x. And in simple language, this is how we read dy by dx. Or we say f dash of x. Sometimes people say f prime of x, or we say f dash of x. This is how we read f dash of x. Power rule. Now if you have a function f of x is equal to x power n, this is in general form. So we are going to talk about the general way of differentiating a function using power rule. This is how it's going to be. We'll have a f dash of x. That means the differential of f dash of x, that will be equal to the power is going to come in front, whatever power you'll have, n is going to come in front, and this dot means multiplied to x, whatever variable you have, it will be multiplied to x, and this power is going to be reduced by 1. So that is why we say n minus 1. So power comes in front and power reduced by 1. N times x, n minus 1. In general, we say multiply the original power n and reduce the power by 1. So you can see that's basically what we have done on top here. We have a function f of x, x power n, f dash of x, n times x, n minus 1. This is what power rule says. Now we are going to look at some examples. For example, you have a function f of x is equal to x cube. How are you going to differentiate this? We are going to differentiate using power rule. How does power rule work? This is how it's going to work. We say f dash of x is equal to the 3 comes in front, 3 gets multiplied in front, the x variable is there, and the power is reduced by 1. Reduce the power by 1, so you have 3 minus 1. Now 3 minus 1 is 2. In simplified form, we have f dash of x is equal to 3x squared. That means f of x is equal to x cube. The differential of that is f dash of x is equal to 3x squared. That's basically power rule. Let's look at another one. When you have a cube root of x, sometimes you are given this way, cube root of x. Remember, this is cube root. This is not 3 multiplied to root of x. The 3 is hanging here, indicating that this is cubic root of x. So when you have in this form, it's best to put this cube in cubic root in power form first. So if you rearrange this, this will look like x power 1/3. Cubic root of x is same as x power 1/3. You can use laws of indices and verify that it comes to x power 1/3. Just like root of x is x power half. Similarly, cubic root of x is x power 1/3. Now if you differentiate x power 1/3, remember this is not a differential form. This is not the derivative of this function. This is still f of x, but we have just rewritten it. We have not differentiated yet. You can see we have not put a f dash of x. That means this is still f of x, but rearranged, or we have just rewritten it. Now we can differentiate this because we have 1/3 in the power. Here we can't differentiate this because we don't have a power here. So that is the reason why we have written in this way, x power 1/3, so that we have a power and then we can play with this power. Now what will happen, this power is going to come in front, just like our rule, power is going to come in front. So we can see 1/3 comes in front meaning it gets multiplied. So 1/3 gets multiplied to x, this x, and this 1/3 is reduced by 1. So 1/3 minus 1. Now if you press this in your calculator, 1/3 minus 1, it comes to negative 2/3, or negative 2/3. That's what we have now. 1/3 times x to the power negative 2/3. So this is the differential of this function. Moving on, derivative of a constant. When we say derivative of a constant, that means when you differentiate a number, any real number. For example, we are going to look at an example after this. So when you differentiate a number k, this is how we denote in general. F of x is equal to k, or we say f of x is a number. Then the differential of that number will be basically 0. So when you differentiate a constant, the result is 0. Looking at one example, f of x is equal to negative 7. So the differential of that will be basically 0 according to this. Another one, f of x is equal to 2/5. Again the result will be 0. So any number, if you differentiate, the result will be 0. If you say f of x is equal to 100, now if you differentiate 100, it will be still 0. If you differentiate 1000, it will be still 0. Or if you differentiate pi is a constant, so differential of pi will be 0. Any number, if you differentiate it, the result will be 0. Constant multiplied to a function, we say constant multiple rule. So if you have a number multiplied to the function, then what will happen, you differentiate the function and at the end you just multiply by the constant that you have initially. So this is how the rule works. If you are given a function y is equal to k, remember k is a number multiplied to f of x. F of x is a function. So if you are finding dy over dx, that means if you are differentiating y with respect to x, then what will happen, this constant here is going to get multiplied to the differential. So that means you are only going to differentiate this function here, f of x. So if you differentiate this f of x, you'll get a result, and whatever result you have, you are going to basically multiply by the constant that you are given. Now let's look at one example that has that kind of situation. For example, here you have 2x power 4. So this 2 is a constant. This constant is multiplied to this function here, x to the power 4. So what we are going to do, you are going to ignore this 2 for a moment, because eventually this 2 is going to get multiplied to the differential. So we're not going to do anything to this 2. So we're going to put this 2 outside for a moment. So we'll say f dash of x is equal to 2, this 2 here, k, so 2 multiplied to this 4. This 4 is coming in front, power rule. So 4 is coming in front, multiplies to x and 4 minus 1. That's what power rule says. The power comes in front or gets multiplied in front, and then it is multiplied to the variable, and whatever the power is there it gets reduced by 1. So this is why we say 4x power 4 minus 1, and this 2 we say it's a constant, so this 2 is also multiplied. So now we have to simplify this. This 2 times 4 becomes 8, and this 4 is just here. Sorry, 4 times 2 is 8, this x is just here, and 4 minus 1 is 3. So your result is 8x cube. Now this is when we have a constant multiplied to a function. That is why it's called constant multiple rule. Another one, you have 3 times, remember this is not cubic root, this time 3 is multiplied to root of x. So when you have this kind of situation, what you actually do, the 3 is outside, right? So 3 is a constant, you just differentiate the function root of x. Now root of x we have to rewrite this. Why? Because we can't see a power, so we have to write this in terms of power. So root of x is same as x power half. Now we are going to rewrite this, so we'll say 3 times x power half. Remember we have just rewritten, we have not differentiated yet, we are just rewriting it. Why we have to rewrite? Because we need to have a power. Root of x we can't see a power. If you want to differentiate this straight away using power rule, you cannot. Why? Because there is no power. So we need to write this in terms of power. So that is why we say x power half, and this 3 is coming here. Now why it's x power half, you can verify using laws of indices. Nth root of x, how do you write that as a indices form, right? So now we can differentiate this because we have a power, so this half can come in front, or we say it gets multiplied in front. So this is how we are going to do. 3 over 2 half times 3 is 3 over 2, this half coming in front. So when this half comes and multiplies in front here, we have 3 times half. 3 times half is same as 3 over 2, and we have x power negative half, because half minus 1 is minus half. So that is why we have minus half here and 3 over 2 here. So basically we say the differential of f of x is 3 over 2 x power negative half. We need to rewrite equation in this form, ax power n, before differentiating. That is why we were putting that in terms of power, root of x or cubic root of x. It has to be in this form, then we can differentiate. We need to have a power. That is why we say it's a power rule. Root sign, write it as a power. Root of x same as x power half. Cubic root of x is same as x power 1/3. Now fourth root of x will be x power 1 over 4, and so on. This is same as 2 times x power 1/3, because this portion here will be written as 1/3, x power 1/3, and this 2 gets multiplied here. And this is the general form, b x power a. So what happens here, x is power a over b. So whatever number you have here goes in the denominator, whatever number you have here goes in the numerator. That is why we see here it's 2 and it's 1 here. So 2 goes in the denominator, the 1 here goes in the numerator. Okay, there is an invisible 2 here, that is why it's called square root. Right? There is an invisible 2, we don't write here 2, but there is an invisible 2 here, so that is why this 2 goes in the denominator according to this rule. Right? According to this rule, whatever number you have here and whatever number you have here, the number that you have here outside goes in the denominator. Whatever number you have here inside with the in power of x, it goes here in the numerator. So here the number in the numerator is 1, invisible 1, so it will go where? It will go in the numerator. You have an invisible 2 here, so this invisible 2 will go in the denominator. Same here, you have 3 here, so this 3 is b, so b is in the denominator, so b will go in the denominator. And you have a invisible 1 here, so invisible 1 is a goes where? In the numerator, so this 1 will go in the numerator. That is why we have x power 1/3. So this is how things work. It works according to this identity here. Okay, bringing any function x in the denominator up to the numerator before differentiating. For example, this one, you have something 2 over x cube. Now you can't differentiate this straight away, right? Because the x has to be in the denominator. Bring any function of x in the denominator up to the numerator. So this x cube needs to go up first before you differentiate. So that is why we say 2x power -3. This has to come up. How does this work? This also works according to laws of indices. So x power 3 becomes x power -3. Another one, you have 2 over cubic root of x. So this cubic root of x has to come in the numerator. So this is how it's going to be, 2x power -1/3. And last one, 1 over 4x cube. So 4x cube has to come up, or x cube has to come up. So you'll have 1 over 4. This x cube, when it goes up, it becomes -3. So remember, if your power is positive in the denominator, and when it goes up it becomes negative. And this is due to the laws of indices. If you look at laws of indices, this is what laws of indices says. If you have 1 over x power n, 1 over x power n, that is same as x power -n. So if you want, you can go and verify using laws of indices. A function is given by x cubed minus 4x squared plus 6x minus 12. Find the derivative of this function. So if you have to differentiate this function, this is how you're going to differentiate. So I have just rewritten it. You are going to differentiate term by term. So differentiate this, differentiate this, differentiate this, and differentiate this. So looking at the first one, x cubed. So power is going to come in front. So what is the power? 3. 3 is going to get multiplied to x, and then 3 minus 1. What is 3 minus 1? 2. So you have 3 multiplied to x power 3 minus 1. Power rule. This one, similar thing, 2 is going to multiply by 4. Remember, this is for constant multiple rule. So 4 multiplied to 2, this 2 is in the power, so it comes in front. This 4 is from here, this x is from here, and 2 minus 1. This one, the power is 1, so you'll have 6 multiplied by 1. There is an invisible 1 here, So that is why it's multiplied to 6 times 1, and it is multiplied to x, this x, and this power is reduced by 1, so 1 minus 1, you have 1 minus 1. And lastly you have 12. And what did we say about differential of constant? Differential of constant is 0, so that is why we put 0 there. Now we have everything done, we just need to simplify this. It's not good to write our answer in this form, all this has to be in simplified form. So 3 minus 1 becomes 2, 3 is multiplied to x power 2, 4 times 2 is 8, x power 1. We usually don't write 1 here, but for the purpose of explanation we have put 1 here, just to denote that 2 minus 1 is 1. And 6 times x power 0, so 1 minus 1 is 0 here, and minus 0 here. Then we further simplify, it becomes 3x squared. Here we have removed this one, so 8x, and 6 times 1. Why we are putting 1 here? Because of this x power 0. X power 0 is 1. This is according to laws of indices. X power 0 is equal to 1. That is why we say 6 times 1. And 6 times 1 is 6. So finally we write our answer in this form. 3x squared minus 8x plus 6. That means if you differentiate this function here, you get this in simplified form. This one you can actually do in your free time. First you need to expand this, so expand using laws of indices. Remember, when you are dealing with powers, be careful, make sure you expand one by one and then you simplify the powers. So you can try this out in your free time.